so we're just continuing with the notes from 6-1, finding that first word problem about Jasmine. Are we all there? Okay. All right, so Jasmine has 35 coins in her wallet, all nickels and quarters. If the total value of the coins is $4.35, how many nickels and how many quarters does she have? Okay, so always read the full problem before you start, because generally what you're looking for is going to be at the bottom. So how many nickels and how many quarters does she have? That's going to tell you what your variables need to represent. How many of you like to use X and Y every single time in a word problem? How many of you are okay with maybe using N for nickels and Q for quarters? Oh, I got some bad looks. Okay, I'm going to do that on this one, and then I'll switch over and use X, Y. So on this one, I'm going to use N equals number of nickels. If you don't want to use N, use X. And Q is number of quarters. I tend to like to use kind of meaningful variables so that at the end, when I get N, I know what N it represents. If it's X, it's like, okay, what was that? Was that the nickels or the quarters? So we're going to use N and Q on this one. Okay, so knowing what I'm looking for tells me what the variables need to represent. Now let's go back and set up our equation. She has 35 coins in her wallet. How would I write an equation for that? Yeah. Number of nickels plus number of quarters is 35 coins. So if you had X and Y, it'd be X plus Y equals 35. The total value is $4.35. How am I going to put that into an equation? How much? What is the value of a nickel? Hold that thought for my next question. Yeah, it's 5 cents. So if we use 5 for 5 cents, we can do that, but we'd have to change this to 435 cents. So you can do it that way. Or we can do 0.05. And what are we going to use, Alex, for quarters? 0.25. You got it. Is $4.35. Okay, so again, if you don't like all the decimals, just use a 5, just use 25, but this becomes 435. Change it all to cents. Okay, so look at this system. Would you use substitution or elimination? And there's not a wrong answer there. Substitution. Don't have any elimination, people? Okay, if you were going to use elimination, I would multiply the top equation by negative 0.05 or negative 0.25. But I heard most substitutions, so we'll go that route. And which one I solve for, neither one is easier, so I'll just solve for the N is 35 minus Q, or negative Q plus 35, if you prefer it written that way. Okay, then I'm taking the 35 minus Q, and I'm plugging it into the other equation in the place of N. So now my equation is 0.05 times 35 minus Q plus 0.25Q equals 4.35. Okay, so next step is what? Distribute. So grab that calculator. Let's do some multiplying here. 1.75 minus 0.05Q plus 0.25Q equals 4.35. And then we're going to add up our like terms. 1.75. What is negative 0.05 plus 0.25? 0.20. You can also just do 0.2. And then I'm going to subtract 1.75. 2.6. And divide by 0.2. What if I got a decimal here? It'd be wrong. Oh, let's see, 2.6 divided by 0.2. Because we don't want a portion of a nickel and a portion of a quarter. Like, those should be integer values, right? If it's just solving an equation, a decimal or a fraction might be fine, but a number of something shouldn't be a decimal or fraction. Okay, so Q is 13. Where's the easiest place to find N? First equation, or right here. I've already got it set up. N equals, so I'm going to use that. 35 minus the quarters. And so N equals 22. Okay, so those are my answers, but let's write the answer in context. How many nickels and how many quarters does she have? So she has 22 nickels and 13 quarters. And that would be the answer I'm looking for. Question? All good? Carson, good? Yeah, you guess. Okay, moving on then. All right, so you tend to see the same types of problems. This is another common problem. You see some kind of movie situation, like they're buying drinks and popcorn and the amount they spend is whatever. So this is a similar one. The admission fee at a carnival is $2.50 for children and $7 for adults. On a certain day, 1,400 people attend the carnival, and the admission fees totaled $5,822. How many children and how many adults attended the carnival that day? Okay, I'll use X and Y for you XY people out there. What do you want X to represent? Yeah, and remember, read that question. That's going to tell you what your variables should represent. How many adults and how many children? So X can be the number of children, and Y can be the number of adults, or vice versa. Okay, so let's go back and read again. The fee is $2.50 for children and $7 for adults. There are 1,400 people. Do those two things go together? Not really. The money goes with the money. The number of people is what will give us the 1,400. So I have X children plus Y adults. That has to equal the 1,400. Then I'm going to take the money information and combine it in a sentence. If each children's ticket is $2.50 and each adult's ticket is $7, and this is how much money they collected, how would I put that into an equation? There you go. Okay, and you could do 2.50 if you want for the $2.50, but you don't have to have that zero on the end. And 7 for the adults and your total amount there. Okay, so look at that one. Should we use substitution or elimination? Not a wrong answer again. Substitution would be easy. Elimination wouldn't be terrible on this one. What would be easiest to multiply by if I wanted to use elimination? I'd probably do -7 up top, or -2.5. Anybody want to do elimination? Y'all are like, no. Okay, solve for X or Y is either easier. Solve for Y this time? All right. Mix it up a little bit. Guys, do y'all have a question? Then zip it. All right, if Y is 1,400 minus X, then I'm going to take that and plug it into the other equation in place of Y and get 2.5X plus 7 times 1,400 minus X equals 5,822. And we're going to do the same thing we did before. We're going to distribute, add like terms, solve for the variable. So let's see what we get. That's 1,400. 800. Jerry, what'd you get?
For Y.
Tell me what you got for X. Or
I got 884.
alright, let's see if I get the same thing. I did. Okay. And what'd you get for Y? I agree. Alright, so then put that in context. Since I let X be the number of children, I have 884 children and 516 adults. Okay, there's some of your work, so I'll give you a chance to finish up. Make sure you get the same thing. Are we good? Any questions? Okay, this next one I think is a little bit harder. How many of you have flown an airplane?
No, it's been like you said.
Oh, flown an airplane. Yeah, any pilots in the house? Okay, so how many of you have flown, say, to the West Coast? Anybody? Okay. Kevin, did you pay attention to whether it took the same amount of time to go out west as it did back? Okay. So if you fly, and you might not have, let's say that we're going to go from Atlanta to Los Angeles. Okay. When we travel in that direction, we will have headwinds. What does that mean? Yeah, we're going against the wind. On a super windy day, you know, if you're walking against the wind, like it's literally harder to walk than if you turn around and the wind's kind of pushing you along. It's a lot easier. So headwind goes against you, slows you down. Tailwind is going in the same direction, and it speeds you up. Okay, so do any of you have relatives, say, Alabama, Mississippi? Okay. Have you ever noticed that their weather comes to us? Like, my mom lives in Mississippi, and she's all about the weather. And she'll be like, oh, we have a terrible storm here today. It's coming to you tomorrow. And she's usually right, because our weather tends to go from west to east. And that headwinds and tailwinds are traveling that direction as well. So if we're going from Atlanta out to Los Angeles, it will take us longer than when we turn around and come back from Los Angeles to Atlanta. Like, it could be 45 minutes difference. Noticeable difference. And of course it depends on how strong the winds are that day, but the trip out is always longer than the trip back just because of the winds. Okay, so this next problem is going to deal with that. So it took Brett 2 hours to fly from Philadelphia to Pittsburgh, a distance of 260 miles, flying into a headwind. Following the same flight path, his return flight was 1 hour and 15 minutes. If the wind speed and direction was the same for both flights, find his speed in still air and the wind speed. What are our variables going to represent? What is it we're looking for? His speed and the wind speed. Okay, so let's let X be one of those and Y be the other. I'm going to come over here. I'm going to say X equals plane's speed and Y equals wind speed. Okay, so generally, like I said, what you're looking for is going to be at the bottom. It's going to tell you what your variables should represent. Now, for this one, we have to use kind of a different setup. we're going to use this formula right here. You've seen that formula before. Maybe in a science class. Any idea what those variables represent? Distance, time, and rate. So rate times time equals distance. So if you're driving 50 miles an hour for 2 hours, you're going to cover 100 miles. Okay? So rate times time equals distance. That's our setup that we're going to use here. Okay, so let's talk about when he goes to Pittsburgh, the first leg of this trip. Okay, what is the rate that he's flying? Well, we don't know. But since he has headwinds, the plane speed will be slowed down by the wind speed. So his rate will be however fast the plane is going minus the wind that's working against it. So that's the rate. How long did he travel? 2 hours. And distance was 260 miles. So that's his rate in parentheses, his time, and his distance. Okay, but coming back, following the same flight path, his return flight was only 1 hour 15 minutes. The wind and speed direction were the same. Okay, so what was his rate returning? Well, it was the plane plus the wind. It was working with them, making them go faster. 1 hour 15 minutes. Is that 1.15? Please say no. No. 15 minutes is how much of an hour? Yeah, fourth of an hour. Picture the clock. 15 minutes is fourth of an hour. Or if it was some weird amount of time and you weren't sure, then we're going to say 15 divided by 60, because there's 60 minutes, is 0.25 of an hour. So his time was 1.25, but the distance was the same. So the time and the rate varied, distance was the same. Is everybody okay with those? Okay, should we use substitution or elimination? Elimination, what should we do first? Distribute. Would anyone have thought to maybe just divide by 2 first? No? Okay, then we won't. Then we'll distribute. Okay, 2x minus 2y equals 260. 1.25x plus 1.25y equals 260. Okay, now substitution or elimination. Substitution. If you use substitution, which equation would you use? Oh, the second one? Okay, top one. All right. All right, I'm going to go with the second one just because she popped up with that first. All right, I'm going to solve it for x. And I know y'all would maybe shy away from this for decimals, but I think it's going to work out okay. Okay, so I moved 1.25y over to the other side. Now I'm going to divide everything by 1.25. So I get x equals 260 divided by 1.25 is 208. And then that's just 1y. Okay, so now I can take this and I'm going to plug it into the other equation. So I'm going to plug it into that top kind of easier looking equation. 2 in the place of x minus 2y equals 260. Distribute the 2, collect like terms. So let's solve it for y. Did you get 39? Okay. Then what I actually found was the wind speed. So I've got to go back and find the airplane speed. Here's the easiest place for me to plug it in, where I already have x isolated. So I'm going to say x is 208 minus 39. So that gives me 169. Okay, so to answer the question, what would this speed be in? Miles per hour. Okay, so, run out of room. Write too big. Okay, so the plane speed would be 169 miles per hour. And then 39 miles per hour is the wind speed. Question. Anybody? Where did this come from? After I simplified that equation, I had this, so I just took my y and plugged it back in there. You could plug it in any equation that you've dealt with. Any other questions? Okay, so let's look at number 16. Marlena bought 1 2/3 pounds of French roast coffee and 3 1/8 pounds of Colombian coffee and paid $31.25. Rowan bought 2 5/12 pounds of French roast coffee and 9/16 pounds of Colombian coffee and paid $15.15. Find the cost per pound of each type of coffee. What are our variables representing? The cost of Colombian and the cost of French roast. Anybody want to use C and F or X and Y? Okay. All right, X I'm going to let equal cost per pound of, I'm just going to say cost of, French roast. And then Y will be cost of Colombian. All right, so let's see how we're going to incorporate this information. She bought, so we have two different people. The equations are going to represent both people. So the first equation is going to be Marlena's equation. She bought 1 2/3 pounds of French roast, 3 1/8 pounds of Colombian, and paid $31.25. Well, each pound of this cost X. Each pound of this cost Y. So to calculate the cost, you would take how much times the cost per pound. So 1 2/3, I don't want to use a decimal because that's a repeating decimal. So let's change it to an improper fraction. That would be 3 plus 2 be 5/3. Remember how to do that? Switch to an improper fraction. 5/3 of that French roast cost. Pounds times cost per pound. Plus 3 1/8. That's 24 plus 1, 25/8 of the Colombian. And all together she paid $31.25. Okay, so we're going to take Rowan's situation, turn it into an equation. That would be 24 plus 5, 29/12 of the French roast, plus 9/16 of the Colombian, cost him $15.15. You take 1 times 3 is 3, add 2 is 5/3. So this one right here, 3 times 8 is 24, plus 1 is 25, so 25 over 8. Okay, any other questions so far? All right, this one's messy, isn't it? I do not think I would be a proponent of elimination here. I think I would definitely use substitution. Should we just solve for x up top? I mean, nothing looks easy here, does it? If I solve this for x, I'm going to have 5/3 x equals 31/25 minus 25/8 y. It's a simple equation. What am I going to do next? Divide everything by 5/3 or multiply everything by 3/5. So you take your pick there. Either way, I think we're going to be using some calculators. 31.25 divided by 5/3. 18.75 minus 25/8 divided by 5/3. 15/8. Okay, that lovely thing is going to be subbed into this lovely equation. All right, so I have 29/12 times that good stuff there. Thank goodness for calculators. Distribute, collect like terms, solve for y. Okay. Gee whiz. Nobody sees a mistake, do they? This is super messy. Paper. These are awful, aren't they? I hope this turns out okay. Cry if it doesn't. Oh! I knew I had a bad feeling. Oh, wait.
How did we get 24, 13 over 8?
Okay, wait. Dang it! Okay, oh, I'm so mad. I should have recorded first block. It went through just fine. All right, where did I mess up? 5/3 x equals that minus that. Say that again. What?
Like where you have 725 over 16, I have 45.3. I have a fraction. Like when you put it in the calculator, it gives you a decimal, but when you change it,
Yeah,
it's still
I converted. Okay, let's see.
two y's together? 145
Mm-hmm.
plus 916. I got negative 127 over 32. Yeah, that's what I got.
Okay, that's what I have here.
Did you add the 725 over to 515?
I think I did, but let me try it again. I subtracted it, right?
Yeah.
Unless I typed a wrong number. Let me double check that one. Nope, that's what I got there.
I don't know. When you do, I did negative 30.1625. And when you divide it, it gives you.
Oh my gosh, this is going to drive me nuts. Okay, I don't know where I went wrong. What did y'all get for Y?
7.6.
Okay, 7.6. And y'all agree with that one? Oh wait, that's what I got when I checked it. Maybe I just typed it in wrong the first time. Let's see if that's right. Yes, that is right. Okay, maybe I just typed it in wrong because when I just did it again, I got 7.6. Okay. Whew. 7.6. Cost of Colombian. To find X, good gracious, I guess I'll plug it in right here. X equals 18.75 minus 15 over 8, ladies, times 7.6. 4.5?
Yes.
Okay, so cost of French roast is, I've used up all my space, so I'm going to write this right here. $4.50. And cost of Colombian is $7.60. That's my answer. Ooh, messy. So in this situation, a decimal is okay. A negative would not be okay in this one, but a decimal would be. And just make sure you type everything correctly in the calculator. All right, last one. We'll set this one up and not finish it out. Alex invested $7,500 in two accounts. One paying 5.5% and the other paying 8% simple interest per year. His, we'll just change it to her. Her annual interest was $540. How much did she invest into each account? What do my variables represent? How much did he invest in each account? The amount that went into the 5.5% account and the amount that went into the 8% account. So there were two accounts. So we want to know how much was deposited into each. Okay, so let's say X is amount in 5.5% account, and Y is amount in 8% account. Okay, he invested $7,500 into these two accounts. Yeah, X plus Y. The amount of that, all together, $7,500. Okay, most of you have probably taken economics, so simple interest is the amount of money you have times the interest. But let's change these to decimals. What is 5.5% as a decimal? 0.055. So you've got to move that decimal 2 places to the left. So I have 0.055 in that account, however much I deposited, plus 8%, which is 0.08, times however much I put into that account, will equal my interest, which was $540. This one's probably another good one for substitution. Solve X or Y in the top equation, plug it into the second. Think you're okay with that? Okay. All right, we are going to do a couple more of these at the end, and then I'm going to set you free and let you work on some stuff here. All right, go to the very back page. And we're going to do... We're going to do 7, 8, and 10 real quick. Okay, look at number 7. Who can tell me what these two things would be if I graphed them? Circle and a line. Awesome, good job. Okay, so they're going to intersect at maybe 0 points, 1 point, at most 2 points. We're not going to graph them. But we're going to solve them algebraically. So look at this system. Would you use substitution or elimination? Substitution. You can't really do elimination, can you? Because there's nothing that'll cancel even if I multiply by something. All right, so what do you want to solve for, x or y? Y, okay. So 2y is negative 3x. What does y equal? Negative 3 halves x. We're okay with that. All right, so that whole thing will be subbed into the other equation in place of y. So I will have x squared plus negative 3 over 2x squared equals 52. Now, when I square that fraction, the negative gets squared, the 3 gets squared, the 2 gets squared, and the x gets squared. So what do I end up with? Y'all can square 3 over 2 in your head. 9 over 4x squared. Okay, these are like terms, so I'm going to add them together. Can we do that in our head? 1 plus 9 fourths. 13 fourths. Nice job. And to solve for x squared, I'm going to do what? Divide first. So let's divide by 13 fourths or multiply by 4 thirteenths. And I'm not going to do that one in my head. If x squared is 16, what is x? Or? Yes. X is 4 or negative 4. 2 answer possibilities there. Okay, so that tells me there's going to be 2 points of intersection. All right, where am I going to find the y's that go with them? Plug them in. Here's a really easy place right here to plug them in. So negative 3 halves times 4, negative 3 halves times negative 4 is negative 6 when I plug in 4. And positive 6 here. So those are my points of intersection. Do you need the papers? Take a look at that and see if you have any questions. We good? All righty. There is a video for yesterday, and I'm recording this as well. Okay, let's jump over to number 8. How would you solve that one? Oh, let me ask this first, though. If I graphed them, what would they be? Parabola on the top one, and a circle on the bottom one. Yes, that's exactly what I would do, I believe. So it's already set up for substitution because it's already solved for y squared. Do I need y? Not really, because there's not even a y here. There's a y squared. So I could just take this whole 2x plus 13 and plug it into y squared. So I get x squared plus 2x plus 13 plus 6x minus 1 is 0. Okay, what would you do next? Yeah, let's simplify. Let's put it in descending order. So I've got the x squared. I have an 8x. And I have a 12. Now we're going to do what? Factor. That lead coefficient of 1 makes it easy. So what do you multiply to get x squared? X times x. What do you multiply by 12 to get 8? 6 and 2, 2 and 6. Doesn't matter which comes first here. Both are plus. Okay, so then I would take each factor and set them equal to 0. What's x going to be right here? And what will x be here? So I get negative 6 and negative 2. Okay, so I know x. So let's go up to that top equation. That one seems a little simpler. So I'm going to say y squared equals 2 times negative 6 plus 13. Well, that's negative 12 plus 13 is 1. If y squared is 1, what is y? Or, oh, okay, so look what happened. I plugged in negative 6, but I got 2 y's. That's 2 ordered pairs. So I'm going to put them up here. When I used x equals negative 6, I got a possible y of 1, but I also got a y of negative 1. So that negative 6 produced 2 different ordered pairs. Okay, let's do the same thing with the x equals negative 2. Y squared equals 2 times negative 2 plus 13. That's negative 4 plus 13 is 9. So if y squared equals 9, what is y? 3 or negative 3. So when I used x equals negative 2, I also got 2 different ordered pairs. One with the 3 and one with the negative 3. So there are actually 4 points of intersection here. So remember we said that was a parabola and a circle? And I think I drew one up here on the board. Yeah, I could have a parabola and a circle. Actually, this would be a sideways parabola. Bad one. And a circle, oh, super bad, could intersect in 4 points. Okay? Any questions on that one? Uh-huh. Any questions? Okay, last one. 10. How would you approach 10? Do what? Okay, good. I'm going to make y'all do something different on this one. I'm going to use elimination. Because, look, everything's lined up. X squared, y squared equals constant. But what if I just multiply this bottom equation by 16? Wouldn't the y squareds go away? Then I would just have x squared. So let's do, we've used substitution a lot. I'm going to do elimination on this one. Okay, so top equation doesn't change. And you could use substitution also. On the bottom, I have 16x squared minus 16y squared equals 336. And I'm going to add. I set it up so that I always add. If you have opposite signs, you add. Sometimes people will set it up where you subtract, but I just make more mistakes when I subtract. 25x squared, 16y squared plus negative 16y squared is gone, equals plus 625. Okay, divide by 25. It's just going to be 25, right? So what's x? 5 and negative 5. So we're going to have at least 2 points of intersection here. Where do you want to plug these answers in? The bottom one? Okay. All right, so 5 squared minus y squared is 21. 25 minus y squared is 21. Subtract 25. Divide by negative 1. And y is 2 and negative 2. Okay, so what I subbed in was 5 for x. So x was 5, and I got 2. But when x was 5, I also got negative 2 for y. So I'm going to just go out on a limb here and guess when I sub in negative 5, the same thing's going to happen. And look, if I go back to here and I just put a negative 5 in right here, is it going to change the rest of that at all? No. So if I square negative 5, I still get 25. So when I sub in negative 5, I also get those two same y values, positive 2 and negative 2. So that gives me 4 points of intersection. That's a lot of algebra. That's some good algebra, isn't it? All right, so you are wondering, what are we going to do next? So pull out that homework from yesterday. You will find 4 lovely word problems, starting with Luke, number 10 here. We are going to do number 10, 11, 12, 13. 10, 11, 12, and 13. And then we are going to add to that mix on the last page 7, 9, and 10. So the word problems 7, 9, and 10. Got it? The answers are on Google Classroom. If you want to check the answers as you go, you're welcome to do that.